Okay, welcome back. I'm going to introduce Trig today with some quick review. I'm going to go fast because this is all stuff we've done a few times in the past. Obviously, as you have difficulty, you'll need to ask some questions, but just want to refresh everybody's memory on some of the basics here. So, first thing to establish, SOHCAHTOA is kind of a standard mnemonic that often used to help us remember sine, cos, and tan. Those trig ratios and how we find each one. Sine opposite over hypotenuse, opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent. So looking at a right angle triangle here, and again, important to remember, we have to have a right angle triangle or we don't have hypotenuse. If we don't have a hypotenuse, then sine, cos, and tan kind of fall by the wayside. So if I'm looking at the red angle here, theta, across from the red angle, opposite of the red angle, is the side that we call the opposite. Beside it is the side we call the adjacent. Adjacent means beside. If I'm looking at alpha, this ends up being my opposite. This ends up being my adjacent. So basically what that establishes is that in order to do any questions, we always have to start with an angle. Focus on an angle, any right angle questions anyways. Focus on an angle, either the angle that we want to find or the angle we already know, and use it as a base point to determine where an opposite and adjacent will be, and that will allow us to then use sine, cos, and tan appropriately. Quick mention over here, cast rule. And basically what the cast rule is just a way of trying to help us remember where things are, where ratios are positive and negative. Essentially, it's pretty self-explanatory. So anything in the first quadrant, all ratios are positive. Second quadrant, sine is only sine is positive. Tan is positive in the third quadrant, and cos is positive in the fourth quadrant. And when we talk about quadrants, we're talking about if we were to graph our angles around a circle. And so essentially anything between 0 and 90 will always give us a positive ratio. Anything between 90 and 180 will give us a positive ratio for sine, but will give us negative ratios for the other two. Anything between 180 and 270, tan is positive only, and anything between 270 and 360 will give us cosine positive. Going the opposite direction is also possible. If we're talking about an angle between 0 and negative 90, cosine is positive. Anything between negative 90 and negative 180, tan is positive, and so on around as well. Okay, so that's super quick. Talking about reciprocal ratios. Reciprocal ratios. Okay, sorry, the reciprocal ratios are cosecant, secant, and cotan, and all they are excuse me, reciprocals of the originals. Cosecant is the same as 1 over sine, secant is the same as 1 over cos, and cotan is the same as 1 over tan, which is to say that cosecant is, again, the reciprocal of sine. Sine is opposite of hypotenuse, so this one is hypotenuse over opposite. Secant is the opposite of 1 over cos, so it's hypotenuse over adjacent. And cotan is the reciprocal of 1 over tan, and so it's adjacent over opposite. So if you are ever asked to find secant, cosecant, or cotan, you just recognize it's the reciprocal of the other one and work it that way. Much more typically, you'd end up with questions kind of off to the side where you know cosecant, you know secant, and you're actually using the reciprocals to solve them. So in the first case, if I have cosecant of 30 is x, I have to recognize that cosecant is the reciprocal of sine, and so I'll rewrite it as 1 over sine is x. And then essentially what I'm looking to do is solve this question. This is just an equation. And so as we've done with any other equation in the past, if I have something, sorry, I'm getting ahead of myself. So essentially, this is 1 over, and sine of 30 is 1/2 or 0.5. And so 2 is our value of x in the first case. Second one's going to be a little bit trickier. Not much, but a little bit. And so understanding that secant is the same as 1 over cos, I can rewrite it in that way. And now, in order to solve this, I have to rearrange it. As if I had 1 over x here, I'd be looking to multiply both sides by x and rearrange it to isolate x. Now I'm going to isolate the cos. And so what I'm technically doing is multiplying both sides by cosine of x. Again, this is the true math behind what I'm doing. If you choose to not write that step in, of course, that's perfectly fine. My cos x divides out with a cos x there. And I can't extend, oh, sorry. Little problem with the smartboard. Okay. Extend. And so what I'm left with now is 1 equal to 1.835 times cosine of x. If I had 1 equals 2x, I would divide both sides by 2. So now I'll divide both sides by the 1.835. I get that same sort of division. / cancellation idea. And so I have 1 over 1.835 is cosine of my x. And haven't mentioned it before, but we want to remember that if we're looking to find the angle, we use the inverse. On our calculator. And I say use the inverse. Your inverse button might be a function, or sorry, it might be a shift button, it may be a second function button, it may be an inverse button. There's sort of a variety of them. Usually it's in the upper left corner of the calculator. And so in order to solve for x, I'm going to do that with the 1.835. And I would ask that you're careful not to punch that into your calculator too soon and lose your accuracy. So I want to actually do inverse cos of 1 over 1.835. You can get a close answer if I divide it through and round it off, but basically, and I find really close to the number 1. Sorry, if I punch that in, do 1 divided by 8.3, 1 divided by 1.835, and I try to round that off too early. Now this one actually works out pretty nicely because it'd be 0.55 almost exactly. But if we round it off too early, we can lose accuracy in our final answers. Didn't realize I was still on there. So 3 quick examples here, and I will do them very quickly. They should all be terrific review. Not terrific review as in terrific, but terrific review as in really reviewy questions. So I have an angle here. I'm focusing on the angle. In all cases, I'm looking to solve for x. So this is my sort of my key point or my starting point. And the 2 sides that I'm going to be dealing with are this one over here, which is opposite my angle, and the hypotenuse of the triangle. So my question basically becomes, given that angle and the fact that I want to deal with the opposite and the hypotenuse, which of the ratios am I going to use? Well, in this case, I'm going to use sine. The opposite is the x. Hypotenuse is the 44. And now, as I would with, again, any other equation, I have a division by 44. I need to multiply both sides by 44. I will have cancellation on the other side. And so this is essentially what I have to work out. And that's going to be 22. Now, it's important to recognize the 44 is multiplied by sine of 30. Don't multiply the 30 by the 44, and then try to find sine of that. You will get the wrong answer. On to B. Again, my focus will be on the angle to start. In this case, it's the angle I want to know. So either an angle that I know or the angle that I want to know is my starting point. And if I had multiple angles, if I had been given the 60 over here, I could have used a 60 just as easily, but I would have been dealing with cosine of the x, or sorry, cosine as my, to get to the x and the hypotenuse, because the x would have been the adjacent. So over here, not sure why I did the same one here. I'm going to switch it up. So assuming this were my question, now, again, the opposite is the side way over here. The adjacent is the side that I have here, and the hypotenuse doesn't change. And so now I'm going to be dealing with cosine to have access to the adjacent and the hypotenuse. Cosine of x is going to be the adjacent 25 over the hypotenuse 40. And so to solve, as we saw a moment ago, I'm going to do this calculation. And for now, we'll make sure our calculators are in degrees. We will be using radians as we proceed. And so x is approximately 51.3 degrees. So one decimal place for degrees is probably ideal for most of the work we do. And now last question. Again, focus on the x here. I have my adjacent, my hypotenuse. And so as we just saw, with adjacent and hypotenuse, we'll be looking for cosine. And again, exact same question as last time. 18 over 16. X is going to be the inverse cos of 18 over 16, which is click, 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 touch, touch, knock, 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 knock. I'm just punching in my calculator. And what? Error. Wah, wah. And of course, the reason for that, if I look at the numbers that I started with, the suggestion was that 18 was my adjacent, 16 was my hypotenuse. And so when I see the error come up, at first I panic, and then I sort of quickly go back to the question and take a look, see what's going on, and recognize that my hypotenuse, by default, by definition, has to be the largest side of the triangle. And so, simply put, this triangle, go back to the red here, therefore, this triangle does not exist. Okay, so just just sort of point to make. I can tell that by paying attention. Don't panic if for some reason something doesn't work out one time. I'm sure you'll run into many questions where there actually is no solution, or the solution is kind of a strange one. So if you do run into something that seems wrong, take a look at it. Obviously, I always check the back of the book, but we know sometimes those are wrong as well. So hopefully that'll get you going for today. And we'll ask questions as we need to.